going to study 3-bit asynchronous up counter. In up counter, they count from 0, 1, 2, 3, that is count from small to big. Here 3-bit up counter, 3 flip-flops are used, and here clear signal is applied to all the 3 flip-flops to set to reset all the flip-flops initially, and here J and K input of all the flip-flops are connected together to the logic 1 level. Therefore, this JK flip-flop acts as a toggle when we are applying negative clock signal or negative clock edge of the each clock pulse. And here first clock signal is applied directly to the flip-flop A, and output of the flip-flop A is given as a clock for a second flip-flop, and output of the second flip-flop is connected to the clock of the third one. Means where A, B, C 3 flip-flops are used here. As 3 bits are 3-bit up counter is there, 3 flip-flops are used, and output of the previous flip-flop is connected to the clock input of the next flip-flop. And here suppose you are applying the initially we are considering all the outputs of the all the flip-flop is 0 0 0. First of all, when you are applying first clock pulse, then what happens? The suppose output of this QA is considered during the first negative clock edge, it toggles, means from 0 it becomes 1. Next clock signal it again becomes 0, next toggles, that is high, again next clock signal, again next clock signal. Means as we are connecting both inputs of this J and K input to the logic 1 level, therefore at each negative edge of the clock pulse, the output QA gets toggled, means 1 to 0, 0 to 1 again, means previous stage we are getting the complement of the previous stage, means 0 1 1 to 0. In this case, for the second flip-flop, this input is again connected to logic 1 level, but here output of the second flip-flop, output of the first flip-flop acts as a clock to the second one, and therefore what happens? Initially it is low during the negative clock pulse. What happens? It gets changed, means toggles, again it gets toggled. Okay. Here the second output is applied to QB is applied as a clock for flip flop C, means third flip flop, and therefore initially QC is low up to 1 clock cycle, as this acts as a clock, means QB output QB acts as a clock for QC, and therefore during this whole cycle the output remains as it is. Here in this counter, number of states is equal to 2 raised to n. Here 3 flip flops are used, 2 raised to 3 is equal to 8, and maximum count is equal to 2 raised to n minus 1, 8 minus 1 is equal to 7, as n is nothing but the number of flip flops. Here the QA acts as a LSB and QC acts as a MSB. The counter output QA, QB, QC is equal to here initially 0 0 0 0 0 1 0 1 0. In third clock cycle 0 1 1, here 1 0 0 1 0 0, here 1 0 1 1 0 1 1 1 0 and 1 1 1, and which is equivalent to 0 1 2 3 4 5 6 and 7. Count is corresponding to the number of clock pulses counter has received, and here all the flip flops are not triggered simultaneously, therefore counter is called asynchronous counter, and input moves from the input towards the output like a ripple in a water, and that's why it is called as a ripple counter. And in each case the frequency of the output of the flip flop get divided by 2, means here for first it is clock divided by 2, for second clock divided by 4, like this. Thank you.